All right, so this will be our second type of sorting that we will be going to tackle, which is all about the insertion sort. So when we say insertion sort, that is talking to a simple sorting algorithm that works by iteratively inserting each element of an unassorted list into its correct position in a sorted portion of the list. So this is actually easy for you, and I want you to really take time to work on this, since the iteration for this will matter n minus one iteration. So this is exciting, and I love this kind of sorting technique since it is simple. So let's actually move on. The algorithm that we can follow in this particular sorting technique will be, we start with the second element of the array, and as first element in the array is assumed to be part of the sorted already, or we assume that the first item or the first number in our array is already sorted. That's why we will begin to start in our first two um, number. So the next one, we have to compare the second element with the first element. If the and check if the second element, if it is smaller than the if the second element, if it is smaller, smaller than the second, the first, if the second element, if smaller than the first element, so we have to swap the two. So we are following here the n minus one iteration, since we are just starting from the second the second element. Next will be move to the third element and compare it with the first two element and put at its correct position. And we have to repeat that uh, recursively until the entire array will be sorted accordingly. Now, let's try to figure out here then. So example, in this particular example array that we have here. So we have 12, 5, 25, 6, 30, 69, 13, 3. Since, as what I mentioned earlier, that the first element was already assumed as sorted already, so we have to be going to check the first two element. If it is if 5 is it less than 12, so we have to swap the two number. So that is how that's how it worked then. So we swap 5, 12, and that will be the first iteration that we do have right now. The second iteration will be going to compare the three elements that we do have in our array. Now, is 25 is less than 5? Is 25 is less than 12? So it's not, so that is already in place already. Now, we have to continue. That is the second iteration, and there's no changes being made right there. The third iteration, we will compare the four elements in our array already. So we have to check that one in every element that we do have in our sorted numbers there. So is 6 is less than 5? No. Is 6 is less than 12? Yes. Since that is less than 12, so we can insert that in the before the 12 then. So we have to insert right there and sort everything. And of course, we're not swapping. Actually, we are just we just insert the element in the specific order, the specific spot that it should be. So it's not swap them. It's we are placing in our algorithm. It should not be swapped. it should be inserted in a correct position. Next, the fourth iteration, we will compare the 5 elements in our array. So therefore, our 30 is the next element. So third, is it less than by 5? No. Is it less than by 6? No. Is it less than by 12? No. Is it less than by 25? No. So since there's no since it's greater than the sorted element, so there's no changes in our fourth iteration. The next iteration will be this number. So is 69 is less than by 5, by 6, by 12, by 25, and 30? It's not. So that signifies as already sorted or already in place. So therefore, there's no changes in our fifth iteration. The sixth iteration, we are comparing here then the 13 in our arrays, in our sorted arrays. Now, is 13 is less than by 5? No. Is it less than by 6? No. Is it less than by 12? No. Is it less than by 25? Yes. Since that is less than by 25, so therefore we are inserting that between 12 and 25. So therefore, 13 is already in place in our sixth iteration. And in our seventh iteration, we will compare the whole numbers that we do have. So is 3, is it less than by 5? Is it less than by 6? Is it less than by 12? Is it by less than by 3? So since that is less than by 5, so therefore, we will be going to insert that in the first index, second 0 index. Now, we will be going to put that there, and that will be our seventh iteration. And that's the end of our insertion sort, that we do have n as 8 array elements in our array, and the iterations that we do have will be 7 because n minus 1, since we are starting that in our second first 2 element in our array. So that's how it worked in our insertion sort. We are just inserting that in a correct position. So, and in the next video, I'll begin to illustrate how to work on with the bubble sort sorting, I mean. So let's move on. Thank you.